Hello, today I'll be giving a tutorial on RealFlow. Um, Basically, it's a fluid dynamics simulator. First, we have Rhino, which I made a basic model of a floor plan which I want to flood. And in order to import geometry into RealFlow, we have to make it into a mesh, but also a triangulated mesh in order for RealFlow to read the geometry. So exporting it as a light wave file, a LWO, is probably the best way in order to get it from Rhino to RealFlow. Just name this model uh, max polygons. So now we open RealFlow, and if we go to import object, we can import our object. First, we should make sure that our scene scale is set to 1, which will allow us to import at a 1-to-1 scale. So now you can see our geometry has imported into RealFlow pretty nicely. The problem with this now, it's pretty big. It is 1-to-1, but for our fluid simulation to be more efficient, we should scale it down. And by using the scaling option, it allows us to have a factored scale in order when we bring it back to scale up our particles. So now I'm doing is adding a square emitter, and that's where our fluids would come from. I'm positioning it in major circulation sort of places to diagram sort of the movement of people as relates to movement of fluids, scaling it down in order for it to fit nicely within our model. And the tip is if you press Control D, it actually makes a copy of the emitter. So by making another copy and placing it on the other end of the model, and again pressing Control D to copy again and placing it at our final main emitter next to the cylindrical area. Make sure it's positioned in the right place. And scale it down a little bit. So now we have our emitters set. What we need to do is place a couple demons in order to control our scene. The first one is adding gravity in order for a more realistic flow of water, and a volume demon would help us control our scene and not allow any particles to escape to be endlessly calculated. So now we have it set. You can see that because we scaled it down, some of the settings are off. So by upping the resolution and the density, we can get more particles to come out at the same time, limiting our max particles. There's also speed and V and H random, which allows for the randomization of particles coming out of our scene, our emitters. So now you could see a steady larger flow of particles, and the result of this test default configurations, you see it's great increase in flooding. So now we want to add another layer to this by animating some of these attributes that would allow us to get a more sort of randomization of the flow of water. So basically what I'm doing is adding keys and moving the timeline, and then subsequently changing the value, adding another key, and then again changing the timeline in order to sort of get an animation of this. And if we right click and open the curves, you can see a graphical display of the animation. Basically the values starting from 3 going up to 6 and then going back to 3. Basically we want to make it smoother, so we make a Bezier at the nodes, and we set the last node behavior to loop, which will basically loop the animation for the duration of the simulation. You can see it loops. It basically, this is just a graphical display of the timeline. See, as I scrub through, you can see the timeline line moving. Now I'll do this for the V and H random, which would allow us a greater dynamic scene in the area. I'm making it simple for this tutorial and just making simple curves that either the values increase at a climax and then decrease back to original value and loop it. But basically, the possibilities are really endless. And this could then lead into further studies where the graphical scale can actually imitate some real world data being streamed in, changing the flow of fluids. So again, doing this for the H random. Now you can see it's more of a asymmetrical curve, which will give us a more random result. You can see it has a drop off at the sort of end. So the result for this animating attributes, you can see it gets a more randomization of the fluids coming out and a greater sort of climax happening. This ends part 1.